Hi guys, welcome to your third grade lesson 7 math lesson. Last time we met before the break, I sent home your handy multiplication chart, and look at how many multiplication facts you guys already know. But we even skipped one, and you guys know even one more than what's presented here, and that's sixes. So we're going to go ahead and start our lesson by filling in the sixes column if you haven't done that already. And then we're going to jump into the lesson and see what other multiplication facts we can add to it. So for sixes, remember we can think about it as splitting it up into double threes because we already know our threes. You can also think about it as 4 and 2 as well. So remember, one of those properties for multiplication, the distributive property, allows us to break up numbers any way we want, and we can still get the same outcome. We can still get the same product. So with sixes, you'll also notice that there's a pattern each time we're adding 6 more, right? So we have 6, and then 6 2 times is 12. 6 3 times, we're going to add 6 more to make it 18. Add 6 more to make it 24. Add 6 more to make it 30. Those are already in there. Those are already facts that we know because we have already filled in our facts for 1s, 2s, 3s, 4s, 5s. So now we're at 6 times 6. So 6 more than 30 is going to be 36. If I add 6 more to that, 36, 37, 38, 39, 40, 41, 42. You can also think of it as like 6 and 6 makes 12. So if we added 12, we would have a 2 in the ones place and 1 more 10, right? And so we're going to have our extra 10 would make it 40. Adding 6 more again, 2 plus 6 would make it 48. And you may also be noticing a pattern in our ones place. We have 6, 2, 8, 4, 0, 6, 2, 8. So now we're going to have a 4 in the ones place. So 6 more than 48, we're going to have 54. And then 6 more than that would get us up to 60. So I filled in my column. Now I'm going to go ahead and finish my row. So I have 36. 6 times 7 is 42. 6 times 8 is 48. 6 times 9 is 54. And 6 times 10 is 60, which is already there. So now we just have this little itty bitty 3x3 square that we don't know our multiplication facts for yet, but hopefully we will by the end of this lesson. So for this lesson, go ahead and turn to page 160. And in this lesson, we're going to be talking about multiplying with 7. So on page 160, you'll notice that there is a problem at the top that says Matt gives crackers to 8 friends. Each friend gets 7 crackers. How many crackers does Matt give away? They have created for us, straighten that out, there we go. They have created for us an array. So it says you can use an array to help you understand the problem. And below that, it says you can also use words and multiplication expressions to help you understand the problem. So first, let's look at the model. They have made an array that has 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, 8 in a column. And then they're breaking that up into 5, so remember we have 8 in each row because we're multiplying 7 times 8. But they're breaking their array into 5 by 8, or 5 times 8. And then another separate 2 by 8. 1, 2, 3, 4, 5, 6, 7, 8. So now we have a 2 by 8 array. So we took 7 times 8. We thought about the 7 as 5 and 2. And so then we made our arrays of 5 by 8, or 5 times 8, and 2 by 8, or 2 times 8. Now remember, 2s and 5s are really nice to work with because we can skip count really easily. So 5 times 8, we could skip count by 5s 8 times. Let's move that out of the way. There we go. So 5, 10, 15, 20, 25, 30, 35, 40. So we would have 40 x's in this array. So 5 times 8 would equal 40. And then over here we have 2 times 8, so we can count by 2s, right? 2, 4, 6, 8, 10, 12, 14, 16. Or we can also think of it as our double stacks. 8 plus 8 equals 16. We've got 2 times 8 equals 16. So we have 16 total x's. Now we're going to add our 2 products together to get our final answer. So 40 plus 16. So we have 6 and 0 in the ones place, so that would give me 6 ones. 4 tens plus 1 more 10 would make it 5 tens. So 7 times 8 would equal 56. So that's the first model. The second model, it says you can also use words and multiplication expressions to help you understand the problem. So you have 8 friends and 7 crackers is the same as 8 friends with 5 crackers each, and then giving them 2 more crackers, right? So what that is saying is I'm going to have 8 friends, 1, 2, 3, 4, 5, 6, 7, 8. Here's my 8 friends. And then I'm going to give each of those friends 5 crackers. 1, 2, 3, 4, 5 for you. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So I've given my 8 friends 5 crackers each. So that's like saying 8 times 5, or I'm sorry, 5 times 8. Ooh, nice new pens, but they don't erase as well. 5 times 8. But then I'm also going to give my friends 2 more crackers each. 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2, 1, 2. So that's like saying I have, oops, come on, teacher Jess, get it together. Not enough coffee yet. 2 times 8 as well. And then I'm going to get my 2 products and add them together, right? So 5 times 8, we already said is 40. 2 times 8 is 16. Added together, they'll get 56. So I've essentially made equal groups, but I've also used that distributive property in the same way that I did with the arrays, thinking of it as 8 times 5 and 8 times 2, adding my products together to get my final answer. All right. Go ahead and turn the page. So number 1 says, so we're now on page 161. Number 1 says, what multiplication problem is Matt trying to solve? Well, we know that we want to give Matt 8 friends 7 crackers each. So 7, 8 times, right? So that's the multiplication problem that we're trying to accomplish here. So when it says, what multiplication problem is Matt trying to solve? We're trying to figure out how to give his 8 friends 7 crackers. And remember, we could write this either way, really. We could say 8 friends with 7 crackers each, or 7 crackers 8 times for 8 friends. Number 2, write an addition expression to show how Matt broke apart 7. So remember, we took 7 and we thought of it as 5 and 2. An addition problem that we would use for that would be 5 plus 2. Or, we can flip-flop those and say 2 plus 5. Number 3 says, rewrite the multiplication expression from problem 1 by replacing the 7 with the addition expression you wrote in problem 2. So they have it written out as 8 times blank is equal to blank times 8 plus blank. Oops. Oh, wait. Nope. They don't have it written out that way. 8 times blank is equal to 8 times blank plus blank in parentheses. So we said 8 times 7 is the same as 8 times 5 plus 2. Now, for step 4, it says complete the equation shown to show the products being added to find the total number of crackers. So first they have 8 times blank plus 8 times blank equals blank plus blank equals blank. So when we are using the distributive property, I'm going to change my pen color here just to be fancy. We're taking 8 and first we're multiplying it by the 5. So we're going to say 8 times 5. Then we're going to take the 8 and we're also going to multiply it by the 2. So then we have 8 times 2. Here we're adding, so we have 8 times 5 added to 8 times 2. Then we're going to find our product. So 8 times 5, we said it's 40. 8 times 2, we said is 16. And when we added those together, we got 56. So that's how you would fill in those blanks, showing the distributive property. All right, let's go ahead and skip on over to page 162. You guys do the problems first, and then we'll go ahead and go over them afterwards. So go ahead and don't do number 9, just do numbers 7 and 8 on your own, and then come on back and we'll check your answers. Okay, did you pause the video and do those? Okay, do that now. Okay, now that you have completed those and unpaused your video again, let's go ahead and look at number 7. So number 7 says use a model and equations to show how knowing the answer to 2 times 7 can help you find 4 times 7. So the problem is asking what is 4 times 7? 4 times 7 is something. But they're saying, just like I said, because we're thinking along the same lines, me and the writers of this book, 4 is really like saying we have double doubles, or 2 and 2, right? So we said that when we were learning 4s, that we could really divide it up and say that we have 7. 1, 2, 3, 4, 5, 6, 7. If I were to make an array, which you might have done for your model to solve the problem, if you wrote an array for 4 times 7, you would have 4 columns and 7 in each column, or you could do 4 rows and 7 in each row. But either way, I'm just going to split that in half, right? And now I have 2 times 7 over here, and then I have 2 times 7 over here as well. Now, we could have done it as 7 times 1 and 7 times 3 as well, but what I really like about 4s is that you can do half the work, right? Because you are figuring out 2 times 7 over here. Well, we know our double stack, so 7 plus 7 would make it 14. And then I don't even have to do anything over here. I just have to write it again because I already solved the problem. So now I have 14 2 times. So if I were to add that together, I would say 14 plus 14. I know that 4 and 4 makes 8 1s, 1 10, and 1 10 make 2 10s. So my answer would be 28. So 4 times 7 would be 28. Now for your model, you may have chosen to do a different drawing rather than an array. You could have used equal groups drawing. And if you did that, maybe you started off giving 2 to your 7 groups, and then you ended up giving 2 more. But I really like the array for working with 4s because you can see that if you split it right down the middle, you're really just doing the same problem twice, double doubles as I call them. All right, so 4 times 7, our answer for that one would be 28. All right, now for number 8, it says show 2 ways you can break apart a factor to find 3 times 7. Write an equation for each way. So they're asking you to show it 2 different models for 3 times 7. So somebody's calling me because they don't know that I'm actually recording right now. So we're going to go ahead and take our 7. We're we're going to start with 3 rows and put 7 in each row. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. All right, so I've made an array that shows 3 times 7. I have 3 rows and 7 in each row. I'm going to switch my pens again to be fancy, because now they're asking you to show 2 different ways that you could break apart the factors to find 3 times 7. So 3 we can really divide into just one way, right? We can divide it into 1 and 2. So that's the first way that I'm going to show. I'm going to go ahead and say that now I have 3, oops, nope. I'm thinking of my 3 as 2 and 1. So now I have 7 times 1 and 7 times 2. So my equation might look something like this. I'm going to actually rewrite it and say that I have 7 times 1. I'm adding 7 times 2. Now I'm going to find my partial product. 7 times 1 is 7. I'm going to add that to 7 2 times, or double 7, which would be 14. And then I'm going to add on to go ahead and find my total answer. So 14, 15, 16, 17, 18, 19, 20, 21. So 3 times 7 would be 21. So this is how I could break apart my model one way, but remember they've asked us to do it 2 ways. If I were going to write my equation for it, I would want to write something like this: 7 times 1 plus 7 times 2, showing how I broke apart the 3 into 2 and 1, and then getting my partial products to find my total answer. So now I'm going to go ahead and erase my blue lines. I'm going to keep my same array, but now I'm going to think about a different way to break up my array. Now really, I can't break up the 3 any other way except for 2 and 1, right? It doesn't matter if we do it 1 and 2 or 2 and 1, it's still showing the same thing. So even if I did it like this, I still have shown the same way of breaking apart the answer. So that leaves me no choice but to go ahead and break apart the 7 in some way. So I'm going to go ahead and choose to break apart the 7 as 4 and 3. So now instead of breaking apart my 3, now I'm thinking about 7 as 4 and 3, or 4 plus 3. So now I'm going to be multiplying both parts of my 7 times the 3. So I have 3 by 4, or 3 times 4. I'm going to put those in parentheses. I'm going to add that to my other side, 3 times 3. Then I'm going to go ahead and find my partial products. 3 4 times, that's going to be like double double. So I know that 3 2 times would be like 3 plus 3, or 6. I'm going to double that again to make it 4. So 6 plus another 6 is going to make it 12. Or that's like adding 3 4 times. 3, 6, 3 more than 6 would be 9. And 3 more than 9 would be 12. So either way, 3 times 4, I'm going to get 12. Now I'm going to add it to my 3 3s. 3, 6, 9. So now I have 12 on one side and 9 on the other. 12 plus 9 is going to get me 21. I still got the same answer for 3 times 7. I just showed it in a different way. Okay, so that's numbers 7 and 8. Go ahead and turn to the next page. 163 and 164 we will be doing in our math lesson tomorrow on Tuesday. So go ahead and keep turning to page 166. So we're continuing to work with, now we're actually going to be working with 8s. So just like we talked about how working with 4 is like double doubles, 8 is going to be like double doubles, right? because you're taking 4 and doubling it to make 8. And so if you had 2 plus 2, that would make it 4. If you have 2 plus 2 again, you're going to have 4 again, and that 4 and 4 together makes 8. So let's go ahead and look at the problem first, because that's always a good place to start. Stella plants 6 rows of pumpkins with 8 pumpkins in each row. How many pumpkins does she plant in all? Okay, so our bottom equation that we are trying to figure out here, we have 6 and we have 8. So we have 6 rows of pumpkins and each row has 8 pumpkins in it. So I'm going to go ahead and start with an array to show that. I have 6 rows, 1, 2, 3, 4, 5, 6. Like my pumpkins? I know they don't really look like pumpkins, but guess what? It doesn't matter because in math pictures, you can go ahead and use simple pictures. So my X's are perfectly good stand-ins for pumpkins in math. Now, in art, not so much. All right, so now I have 6 rows. So now I'm going to put 8 in each row, right? 1, 2, 3, 4, 5, 6, 7, 8. I'm going to do 8 in the next row. 8 in the next row. In fact, I'm going to do 8 in all of the rows. Poor Stella, she is out planting pumpkins for such a long time. Okay, so now that I have my 8 pumpkins in each row, now I'm going to think about some different ways that I can go ahead and break up my arrays to think about 8 in a different way, right? So I can think about 8 as 4 plus 4, which would mean that I'm splitting my array in half, right? Because we already know our forest facts. That's the wonderful thing about the distributive property is that we already know so many math facts, and those can help us we can use that knowledge to help us solve other math facts. So now I have said that I have 6 4 times over here, and I have 6 another 4 times over here. And remember, what's really nice about being able to split your array in half is that you do half the work. So you're only having to solve the problem once. We all like to do less work, right? Okay. So we have 6 times 4. So I'm going to go ahead and think about, I have 6 doubled would be 12. I'm going to double my double. So 6 plus 6 would be like 6 2 times. And then I'm going to double that. So 12 plus 12 is going to get me 24. So I have 24 over here, but I can go ahead and write it twice because I have the same thing over here. So now if I took my 24 and 24, add them together, 4 ones and 4 ones is 8 ones, 2 tens and 2 more tens makes it 4 tens. My total answer up here, 6 times 8, would be 48. So that's one way that we can go ahead and think about 8, breaking it apart into 4 and 4, right? But we can also break it down even further. So that's what the first model on page 166 is showing you. The second model is saying that we're going to take 8 again, but this time instead of breaking it into 4 and 4, we're going to break it up even smaller. We're going to say that 8 is really like 2 plus 2, which would be 4 plus 2 plus 2. So remember how I said double, double, doubles? This is exactly what we are doing with that. We have 8 doubled, doubled, doubled. Okay? So double, double, 2 plus 2. And then we're going to double that by doing it again, another 2 plus 2. So what that's going to look like on my array is I'm going to take 2. Wait a minute. 1, 2, 3, 4. Yeah. I'm going to take 2 because I'm breaking up my 8. And I'm going to say I have 6 2 times, 6 another 2 times, 6 another 2 times, 6 another 2 times. So that's like saying I have 6 times 2, 6 times 2, 6 times 2, 6 times 2, right? 6 times 2 here, 6 times 2 here, 6 times 2 here, 6 times 2 here. And because I'm lazy, I'm not going to write out all of those equations. I'm just going to go ahead and think about what the answer is. I know that 6 2 times 6 doubled is going to be 12. So I'm just going to write, we have 12 here. Then I have 12 here. Then I have 12 here. And then I have 12 here. Now if I add up my 12s, again, I can think about it. I'm going to switch pen colors again. I have a double stack, 12 plus 12 is going to be 24, but I have it 2 times, right? Here's another 12 plus 12, so I have another 24. So my double, 24 and 24 is going to get us the same 48 that we got the first time, okay? All right, go ahead and turn to page 167. And now we're going to go ahead and, from the previous page's models, we're going to answer some of the questions on page 167. So the first one says, look at the first modelet and fill in the blanks to show the factor that 8 is broken into. So for the first one, we said that we have 6 times blank plus blank. And our 2 blanks would make 8. We know that we broke it apart in half, so we said that 4 and 4 would make 8. So our first equation would be 6 times 4 plus 4. Now 2 says to fill in the blanks to show how you can use 2 simpler problems to find the product. So we're going to go ahead and rewrite it now as we have 6 times blank plus 6 times blank equals blank plus blank equals. So we're saying that we have 6, we're multiplying it by the first 4, so 6 times 4. We're doing it again, 6 times the other 4. So then I'm going to get my partial product. 6 times 4 I know is like 12 2 times, or doubles for 4s. 12 and 12 would make it 24. I'm going to just write in the same thing over here because it's still true. 6 times 4 is 24. Add them together and I get 48. So that's how we would fill in the blanks for number 2. Number 3 says look at the second modelet and fill in the blanks to show how the factor 8 is broken apart. So now this one, we're breaking it apart even more. Instead of just breaking it into 2 numbers, we're saying 6 times blank plus blank plus blank plus blank. And we said that each of those blanks is going to be like 2, right? So 2 plus 2 is 4, 6, 8. So if we have 4 2s, it's the same thing as saying we have 6 times 8, right? 6 2s 4 times. 2, 4, 6, 8. Now number 4 is where it's going to get really fun and a little bit tricky because now we're going to fill in the blanks, but we have a lot of blanks to fill in. So fill in the blanks to show how you could use 4 simpler problems to find the product. So they have it as 6 times blank plus 6 times blank plus 6 times blank plus, oops, that was supposed to be a parenthesis that got a little out of control. 6 times blank equals, okay? So just like I did before, I'm going to take my 6 and multiply it by the first 2. So that's going to go in my first spot. Multiply it by the second 2. That goes in my next spot. Multiply it by the third 2 in the third spot. Oops, just kidding. Still 2. And 6 multiplied by the last 2 in the last spot. So now I have 6 times 2 plus 6 times 2 plus 6 times 2 plus 6 times 2. But now I have my equals, right? So now I need to think about what the partial product is going to be. 1, 2, 3, 4 times. So I'm going to get a product here. 6 times 2 is 12. But because I'm doing it again, I can just go ahead and copy and paste myself. So 12, 12, 12. I'm adding 12 1, 2, 3, 4 times because I multiplied 6 times 2 4 times. Now I'm going to go ahead and add them up to find my answer. So 12 plus 12, remember I already did this, and I like to take shortcuts in math. I said 12 and 12 is 24. Another 12 and 12 is another 24. So really it's like adding 24 and 24, which we already did. 4 ones and 4 ones would make 8 ones. 2 tens and another 2 tens would make it 4 tens, or 48. So we get the same answer no matter how many ways we split up our numbers. Okay, moving on to page 168. Again, I want you to pause the video, do numbers 7 and 8 on your own. Do not worry about number 9 because this is kind of a longer lesson, and so we're cutting some of those out for the sake of time. So just focus on numbers 7 and 8 and then resume the video and we'll review them. All right, so now that you've done numbers 7 and 8 on your own, we're going to go ahead and look at them together. So number 7, there we go. Number 7 says we have use the model for 7 times 8 to show how you can break apart 8 to find the product. All right, so they've given us a model. They're saying we have, let me just count here. Okay. 1, 2, 3, 4, 5, 6, 7 rows. And 1, 2, 3, 4, no, 1, 2, 3, 4, 5, 6, 7, 8 in each row. So I'm going to go ahead and create the same model real quick that they've given to you. Now, you can divide your model in lots of different ways. So the way that I'm going over may not be the way that you went over on your paper, and that is totally okay. There are lots of different ways to break up numbers, especially as our numbers start getting larger, like 8. But we're starting off with 7 times 8. 1, 2, 3, 4, 5, 6, 7. Yep, 7 times 8 is our problem. So now how I'm going to break this up, because I like having my work, I'm going to have my array. And now I'm saying that I have 7 times 4 and another 7 times 4. So again, you might like to make yourself work a little bit harder. You may have decided to break up your array in a different way. That's okay. But this is the way that I'm going to do it because I like to take shortcuts. So now I'm going to have 7 times 4, right? But I'm just going to find the answer one time and then write it twice. So I'm going to think of double doubles. So 7 2 times is 14. Double that 14 and it's going to be 28. So I have 28 over here and I have 28 over here. Now I'm going to add those two together. 28 plus 28 equals, I'm going to start by adding my ones. 8 and 8 is 16, so I'm going to put a 6 in the ones place and have an extra group of tens. 2 tens and 2 tens plus one more 10 would make it 5 tens, so my answer would be 56. So 7 times 8 equals 56. Now again, you may have decided to break up your array into a different way, and that's totally, totally fine. But the nice thing about breaking it into doubles or double doubles, 4s, is that then you only have to do half the work. All right, number 8 says, use what you know about 5 times 2 to find 5 times 8 and show your work. Are you starting to see a trend with how these questions are going? Last time it said show 2 ways. Oh wait, maybe there isn't a trend. Maybe I'm making stuff up. Anyway, it doesn't even matter. Okay, so number 8, use what you know about 5 times 2 to find 5 times 8. So we're trying to find what 5 times 8 is. But they're saying use what you know. We already know 5 times 2. So we're going to use that knowledge to find 5 times 8. So we know 5 times 2 is 10. right? Because we know our doubles facts. So we're going to think about 8 as 2 plus 2 is 4 plus 2 more is 6 plus 2 more is 8. So really, I'm going to think about it as I have 5 times 2, 1, 2, 3, 4 times, or I'm adding up 10 plus 10 plus 10 plus 10, 10 4 times, 10, 20, 30, 40. So we can tell that 8 times 5 is going to be 40. We figured that out by using what we know already about 5 times 2. Okay? All right, I know that one went kind of fast, but remember, the beauty about having a video recorded lesson is that you can always rewind and rewatch it. All right, so pages 169 and 170 we will also be covering tomorrow in our practice session. Pages 171 through 174 are there for you to do some extra practice if you would like. But before you log out, we have some important work to do. We need to go ahead and fill in more of our multiplication chart because we have just learned more facts. So we now know our 7 facts and we now know our 8 facts as well. So we can go ahead and think about, we already know 7 facts up to 6. Now we're going to think about 7 sevens. So I'm going to think about that as 7 times 3 plus 4. I'm going to say 7 times 3 is 21. 7 times, let's do it this way, 7 times 4 is 28. If I add 21 and 28, 8 plus 1 more makes it 9. 2 and 2 makes it 4. 7 times 7 is going to get me 49. Now we have 7 times 8. I'm going to go ahead and instead of thinking about it as 3 plus 4, I'm going to think about it as 7 times 4 plus 4 because then I only have to find the answer once. 7 times 4, again, if I follow my line, is 28. And then it's like adding 28 again. 8 and 8 makes 16. So 6 ones and 1 extra group of 10s. 2 10s, 2 10s, and 1 more 10 makes it 5 10s. So 7 times 8 is going to be 56 here. And 7 times 8 is going to also be 56 here. Okay. Now we have 7 times 9. 7 times 9. And I can think of that as 7 times 3 plus 3. Nope. Because it's 3 times 3. It would be like 3 plus 3 plus 3. Okay, or I can break up my 7 and instead say that I have 9 times 3 plus 4. Let's do it that way. So 9 times 3, I can go ahead and check my chart. I have 9, go over to 3, that would be 27. I'm going to add it to 9 times 4, which is going to be 36. 6 and 7, that's pretty close to 6 plus 6. 6 plus 6 is 12. 7 is 1 more, so my answer is going to be 1 more. That would make it 13. 3 in the ones place. 1 extra 10. 3, 4, 5, 1 more makes it 6. So 7 times 9 is going to be 63 here and 63 here. So now we've completed our 7s column and 7s row. That didn't take very long because we only had 3 boxes that we had left to fill in. Now we have even fewer for our 8s. So now I'm going to change gears. We have 8 times 8. And I'm going to think about 8 times 8 as like 4. 8 times 4 plus 8 times 4. So 8 times 4 is 32. Double doubles, I'm going to add it again to make 64. So I'm going to write in 64 here. And now I have 8 times 9. But I'm going to flip-flop those and actually make it 9 times 8 because then I can say 9 times 4 plus 4 doubles rather. So 9 times 4 is going to be 36. Add it again. 6 and 6 makes 12. 2 in the ones place, 1 more 10. 3 and 3 makes 6, plus 1 more makes it 7. So I would have 72 here and 72 here. Yeah. And I can also double check that by saying here I have 9 sevens. If I add, I'm sorry, I have 7 nines. So then if I had 8 nines, I would have 9 more than 63. Let's double check that. So 63, 64, 65, 66, 67, 68, 69, 70, 71, 72. That's adding 9 more. And bingo, we have 72 again. So now the last one, we are left with one last box that is filled in. And I know some of you, Olive, are going to have a really hard time leaving that one box unmarked because the rest of your graph is all filled in. But I'm going to ask you to hold off because I have a really cool 9s trick to share with you next time. In fact, I have 3 really cool 9s tricks to share with you next time. So leave that one little box blank so that we can have the gratification of filling it in the next time we meet. And I will see you guys tomorrow for our math meeting to go over your practice pages. All right, bye.